Dr. Zach, the name you always hated and complained about is now Decimal Z. And from now on, this is my logo. What you're gonna say about this side.
Decimal Z. Decimal Z. Decimal Z. Decimal Z.
Hi Flat Earthers, this is Zach.
This video was made in collaboration with Nick from Nowov channel.
We have already talked in many videos about the shape of the Earth, and we want to make this clear. We already know that the Earth is flat, but only a few Flat Earthers know the problems that the Flat Earth model has yet to solve. And this is not to discredit the Flat Earth in any way. Our position is clear, but we have to understand all aspects well if we want to make a complete analysis on the subject. We must face the problems that come our way and work together to solve them. One of the problems which we as Flat Earth researchers did not pass up can be summed up in one word: angles. It is a very interesting topic, so let's see what it is about. We must first know and understand how the globe came to be from scratch. For this, we have to travel back to the past, but you must drop everything you have learned about space, planets, spherical Earth, and everything else you have learned until now. Thousands of years ago, the first humans tried to understand and study the universe. If you picture yourself in that era trying to do the same thing, the first thing you would do, being an intelligent human being, is create time. To create time, you probably need the lights that revolve around you. So, what is the best light to start with? The sun, because it is the greatest light and it is what we see every day. So, starting with the sun would be okay. You start by putting a stick perpendicular to the ground. You observe and realize that the shadow draws different semicircles throughout the year. Then you see that the sun moves further away and comes back later. The weather changes as the sun and moon move. Then you start thinking about seasons. Then you realize that you need something to navigate, so you create the compass. Then you realize that all the other lights in the sky are connected. Then you create the astrolabe to measure the angles of each of the lights in the sky at the same time. So you keep discovering and learning more until you finally create the signs of the zodiac, knowing that the magnetic energy of the stars can affect people too. Imagine the energy that moves the oceans can do to the human body.
Si lees lo que ponen diariamente, ¿cómo los vas a creer? Es normal que digas, vaya tontería, pero si te fijas en los puntos originales de cada signo te darás cuenta que hay una gran ciencia o incluso magia por detrás. Lo miras por donde lo miras, tarde o temprano, y llegarás a la misma conclusión. Lo que hay en el cielo nos puede afectar aquí en la tierra.
So, you get smarter and smarter until you decide to know the shape of the place where you live. You only have sunlight, shadows, probably a tape measure, and your brain. To understand this, I invite you to stay and watch the entire video, because it is very important and it is not that difficult to understand. Now we are located 2,000 years ago, in the time of Eratosthenes. At that time, you would probably believe that the Earth is flat, because it is exactly what you observe. The first thing you might want to do to understand the universe is to measure the distances between us and the sun, moon, and stars. To do this, you will have to triangulate them. So obviously you're gonna start with the sun. So you're gonna need at least 2 sticks. You're gonna place them on the ground as far as possible from each other because the sun is obviously big. Then you measure the shadow of the 2 sticks at the same time to get the elevation angles of the sun, and then you measure the distance between them. So for example, if the distance between these 2 points is 2074 miles and their elevation angles are both 75 degrees, then the distance to the sun will be 3870 miles. Here is the math behind it. It is very simple. But here is the problem that made people of that time doubt that the earth is flat. Look at this diagram. This is the earth, this is the sun, and these are the angles of the sun during the 12 hours of the day. If you are here at 75 degrees and a friend of yours is here, but on the other side at 75 degrees, the altitude of the sun will be 3870 miles. So, if you want to do the same experiments with more people at the same time, but from other positions on Earth that are on the same line, they won't get the same results. And there is the problem. You and your friend will get the same distance as before, but the other people who are further away from each other will get smaller distances to the sun, even if they are all doing the experiments at the same time. The altitude of the sun will be lower for the second person, and for the third, it will be even lower, and so on and so forth. But how is this possible? The angles should only intersect in one point because we only have one sun and not many suns. So how can other people see it at different altitudes? How does the sun set and rise? This graph was made by me based on real angles and real scales. So what would you do to solve this problem? Based on these results, if the earth is flat, there may be no way to solve it. Let it be clear that the objective is just to understand this issue. We are not saying that the earth is a globe. We know from many evidences that it is flat. In the next videos, we will talk about the problems of the ball, but for now, let's just continue with this topic. As I already mentioned, all angles have to intersect in one point. For example, if you are in a hallway and you put a spotlight in the middle, you walk away and measure the elevation angle of that spotlight, you will get the distance to it, which will be pointing directly at that spotlight. If you move further and do the same thing, you will get the exact distance to the spotlight. This is how it works. But when it comes to the sun, it doesn't work that way. So Eratosthenes, or whoever did this experiment for the first time, realized that the earth could not be flat because of this specific problem. So they thought about curving the earth downwards to make the geometry work, because it has to work one way or another. What happens when the earth curves downwards? The angles of the elevation start to move upward. So what will happen if we keep bending it downwards? Eventually, these angles will become parallel to each other and will continue to coincide with reality, because by curving the earth downwards, we don't change the shadows at all. In this case, we will have only one sun, because all these lines are pointing to one direction, because they are parallel to each other. This is why they tell us that the sun rays are parallel.
Pues, ¿qué ocurre cuando queremos hacer o queremos dibujar los ángulos de elevación en una tierra plana? En este ejemplo, la tierra plana es el papel, ¿vale? Y los ángulos de elevación son estos dos palos que tengo, bueno, los 4 palos que tengo en los laterales. El palo del medio es el ángulo 90 grados que va directamente hacia el sol. Y todos estamos viendo el sol al mismo tiempo, ¿vale? Pero los que están muy lejos están viendo el sol muy abajo, pero los que están muy cerca al punto 90 grados lo están viendo un pelín más arriba, ¿no? ¿Y eso qué quiere decir? ¿Que tenemos 2 soles? No, sabemos que hay solamente un sol. Entonces, en este caso, ¿cómo vamos a solucionar el problema en la tierra plana? pues hace 2000 años supuestamente no sabían cómo solucionarlo. Entonces lo que han hecho es curvar la Tierra. ¿Y qué ocurre cuando empezamos a curvar la Tierra hacia abajo? Las líneas empiezan a separarse desde arriba y al final llegan a ser paralelas, ¿vale?
In other words, they curve the Earth so that the angles start to make sense. So the question is, how much should we curve the Earth to make these lines parallel to each other without changing the angles, of course? Because these angles are immutable, as they can be measured in real life. What is the circumference that can make all these lines appear parallel and at the same time intersect at one point in the sky? How do we do that? It seems impossible. Parallel means they can't intersect, but we must make them intersect or the ball model will fail too. They told us that Eratosthenes measured the circumference of the Earth using shadows only. How did he do it? If you got the angles and you were smart enough to realize that after every 1037 miles, starting from the 90-degree angle, it is always 15 degrees minus. You will see a formula through these numbers and you will be able to make a shape out of it. Anyone with a simple math brain can do that. If you want to curve it down, you must create a circle with this exact radius of 3,959 miles. And there is no other radius that will work for the ball Earth and match reality. And all you have to do is follow the mathematics of Eratosthenes. Let's explain it. We must take a circle and divide it into 24 equal parts. Each part represents 1 hour. It is the time we use today. And as I said before, humans created time. We chose the day to be 24 hours for some reason. So if we divide a circle into 24 hours, what will happen? No matter how big the circle is, all of these angles will remain the same. When you divide the circle by 24 hours, you get 15 degrees at each angle. Once you get this done, you will have to do something else. You have to draw a line from the center of the circle to the sun. So if you want to measure the angle of the sun, it will give you 90 degrees, no matter how big the circle or the ball is. This angle will be 90 degrees and this will always be 75 degrees and this one 60 degrees and so on and so forth on all scales. So there will always be 15 degrees between each line. By doing this, we are already assuming that the light rays are parallel to each other. For now, this is the only way to make the angles work. So what do we do next? We need to know the actual circumference of the circle. If we assume that the Earth is a globe, then it has to have a circumference. How do we measure the circumference using the real angles of the sun? Here comes Eratosthenes, who supposedly calculated it 2,000 years ago. And today, we still use his math as a proof. What he did was measure the distance in real life between this 90-degree angle, Syene, and the second point on Earth, Alexandria. And then he measured the angle of it and did his famous math and got 25,000 miles. So yes, by knowing the circumference, all the elevation angles that we observe will begin to match reality. If you go anywhere in this circle, all you have to do is measure your angle, and if you compare it to real life, you will get exactly the same angle. It's really a cool idea, because you can tell where people are just by knowing their elevation angle and azimuth. You can also know what their angle of elevation is simply by knowing the distance to them. You can even draw the map of the Earth using these angles. And you don't even need a satellite or a plane to do it. Do you see the catch here? All people will think that this is the true model even if they have never really seen the shape of the Earth. So imagine if we can make the angles work on a flat Earth. We will win the debate forever because all the other evidences can support the flat Earth, but not this one. But after knowing the circumference of the Earth, the size can never be changed, because any change in the circumference will cause the angles to change too. But in real life, the angles cannot be changed, so no one can mess with the angles. This data is important because many people think that the globe may not be the size that we have been told and that it can be bigger. That is false, because if the ball is bigger, the real angles will not work on it. The angles of the sun in real life force us to have a single circumference, which is the one we use today. Any change in size, the angles will start to change and will not match reality. So after discovering the circumference, they realized that they had a little problem. How can the sun rays reach Earth in parallel lines? If the sun is a circle or a ball, then all the light rays have to come from the center. That is to say, from one point as seen here. They clearly realized that light rays cannot be parallel because they must intersect in one point. So, for the math to work, the sun cannot be close to Earth because the further away you place the sun, the more parallel the angles will appear.
Entonces ya tenemos líneas paralelas. Esas líneas no tienen que llevar al Sol, pero el Sol es una bola, entonces esas líneas tienen que cruzar en un punto en el centro del Sol. ¿Y cómo lo vamos a hacer? Pues solamente hay una solución, porque matemáticamente las líneas paralelas no pueden cruzar en ningún sitio, ¿no? Pero nosotros tenemos que hacerla cruzar, que si no vamos a tener un problema. Entonces vamos a poner el Sol lo más lejos posible, ¿vale? Y en este caso, ¿qué va a pasar? Las líneas, los rayos del Sol, digamos, van a aparecer como paralelos, ¿no? Van a aparecer como paralelos desde nuestro punto de vista, desde la Tierra, pero van a cruzar en el Sol, en un punto. Paralelos desde la Tierra, pero van a cruzar en el Sol. Entonces, solamente la única opción es poner el Sol lo más lejos posible.
The size is not a problem because we already know the angular diameter of the sun, 0.52 degrees, because it can be measured by simple tools. So wherever we decide to put the sun, the angular diameter will help us calculate the size. So they have to put it as far as possible in the model so that we can see the light rays parallel to each other from Earth. So that means that if the sun is 93 million miles away, the difference between the parallel lines will be immeasurable. The further away the sun is, the better your math will work, and no one will know what they are doing. But if you ask them how they triangulated the sun, they will get nervous, because they will have to use their fake trip to the moon. They only need the size when it comes to an eclipse, but when it comes to angles, they only deal with the sun as a point, because the size of the sun can be determined as long as you have the distance. If you have the distance, you have the size. If you have the size, you have the distance. That's all. So if you modify the distance, you have to modify the size. This is how it works. In fact, the distance to the sun has always changed throughout history. And every time they change the distance to the sun, they readjust everything else. But something strange happened in 2017 in the largest eclipse of the year over the United States. On August 21st, on their own website, they say that the duration of the eclipse is 5 hours. So if you do the calculations of the globe model, you will see that the eclipse should only last 4 hours and something. So with this eclipse, they have almost an hour to spare, and they know it. At that time, several NASA scientists began to say that the sun is much larger than they thought. They admitted that they need to increase the size of the sun to make the eclipse and the math match reality. The news came out in different media and several notes were replicated. They said that the sun was 250 times bigger than the actual size they have told us. But now, those news articles disappeared from the internet, and all we can find now is that NASA scientists say that the size of the sun has to be a bit bigger so the eclipse calculations can work more precisely. This is very relevant because what they are clearly saying is that the size of the sun is a theory, and of course the distance to it is also a theory, but most people do not know about this. We know that the angular diameter of the sun and moon are equal to 0.52 degrees, and this can never be changed because anyone can measure it. So if you claim that the distance to the sun is exactly 93 million miles away, then the size has to be exactly 844,038 miles. It can't be what they want. If they change the size, they will be forced to change the distance to keep the angular diameter as it is in real life. So right now, they are saying that for the math to work perfectly, the size of the sun has to be a few hundred miles larger than the actual size. But if you make the sun 250 times larger, you will put it so far away that the distance will be much greater, enormous. And what does that mean? If you change the distance, you would have a bigger problem, because if the Earth orbits the sun, you are changing the radius of the Earth's orbit. Also, by changing the size of the sun, you would have to change the speed of the Earth, and by changing the speed of the Earth, you would have to change the speed of the moon, because it orbits the Earth. You would also have to change the distance and the sizes of all planets. That is to say, if you change this and that, everything will be out of square, and you will have to change the entire model. But they are too smart to do that in this era of internet. They will never change it because it would make everyone doubt the official science. So they better ignore it and not talk about it anymore. But we will not let that go. So the question is, did they teach us facts or just theories? If your calculations work, does it mean that the world we live in is exactly what your calculations say? The answer is no, because they are constantly contradicting their own calculations. Look what they said about the atmosphere. It's always been 300 miles up. They taught us that as a fact. But now they are saying that the atmosphere extends far beyond the moon. So the globe model is not the truth. We can say that in some things it works better than the flat earth model. We can say that it is more accurate and the one we rely on today. But is it the true shape of the earth? Of course not. Also, you can't compare that model with ours because we barely started it a few years ago and we don't even have their budget. But let's get back to our topic. As we said at the beginning, the biggest problem with our model is the angles. Apparently, they don't work on the flat earth, and we have to make them work. But how do we do that? This cannot be solved by playing with maps or discussing which map is correct or using flight durations, time zones, Coriolis effects, and so on. If we want to create the correct model, we have to solve the problem of the angles, because once the angles are in the right directions, the map will be accurate. If you fix the map, everything else will work. We must mathematically understand why this person sees the sun at this altitude, while this other person at the same time and in another position sees the sun at a different altitude. According to our studies, there are two options. One, curve the earth downwards and make the light rays parallel to each other as we have seen. 2. Refraction. Curve the sky and create an individual curved sky for each eye and make it function as a concave lens, which distributes the light rays in a way that makes all the angles work as in the bulb model. This may sound strange, but I did it and it worked.
Pues algunas personas creen que para triangular el Sol solo hace falta dos palos para medir los ángulos de elevación y la distancia entre los palos. Eso sería correcto para medir la distancia entre esta lámpara y el suelo, pero no para medir el Sol y la Tierra. ¿Y cuál es la diferencia? Pues cuando se habla del Sol hay que considerar la atmósfera. Aquí no hay atmósfera, ¿vale? ¿Y qué hace la atmósfera? Pues la atmósfera causa la refracción. ¿Y eso qué quiere decir? Pues quiere decir que el sol que vemos no es el sol verdadero, sino el sol aparente, por lo cual no podemos medir la distancia a un sol aparente, que es solamente una imagen falsa del sol real, no lo podemos medir.
We published this video here 2 or 3 years ago. In the description you can find the link to it for further explanation, or visit my channel Decimal Z and see more videos. The experiment is summarized as follows. Imagine that you are standing on a big flat table and they tell you that you have to know the shape of that table using the shadows or the elevation angles, but you have no idea how high the light is. You should be able to tell that the table is flat because wherever you go, all the shadows intersect in the center of the lights and you get the same distances. And knowing the elevation angles and the distances between objects can help you know how far away the light is. It is that easy because in this case there is no refraction that affects the light rays. then imagine that you have to do the same, but they don't tell you that up there is a lens that refracts the light. When the refraction occurs, it becomes impossible to triangulate the light source, especially if you don't know which lens was used. So you stand in there trying to triangulate the light using the same method as in the first part. You will realize that the lines will not intersect anywhere because of the refraction they did not tell you about. Then you will think that the shape of the table you are standing on is not flat. This is gonna be your answer if they didn't tell you anything about refraction that affects the light or the shadows you see. If you knew, you would have done a different math. If you are there at that big table without knowing that there is a lens that refracts the light above you, then according to the calculations of Eratosthenes, you will think that you are standing on a ball and that the light source is very far away, which makes the light rays be parallel, because this is the only way to make your model work when refraction is the hidden key. The Eratosthenes calculations in this case that does not include refraction turned the flat table into a spherical table, which makes me think that it did the same thing to our flat Earth. The lens in the experiment is the atmosphere in reality. The atmosphere acts like a concave lens. How do we know this? There is a laser experiment that our team did which proves that the atmosphere makes light go upwards instead of downwards. Therefore, this theory must be taken into account. The atmosphere acts like a lens. A lens can make the sun go down like this experiment by Rob Skiba. If you want to understand this better, you can watch the videos about how the sun and the stars rise and set on the flat Earth. So by bending the sky and squashing the Earth, you can fix the elevation angle issues, and I have already solved that. But there is still a bigger issue, which is the azimuth, but we are working on solving it. So first we need to make the angles work. We got questions like, is the real sun higher or lower than what it appears to be? Because even official science agrees that what we see is the apparent sun and not the real sun. This is another thing that makes you wonder how they could measure the distance to the real sun if we only see a reflection of it. If we just see an apparent sun, then the sun cannot be triangulated. Therefore, the distance to it should remain unknown. If those angles had intersected at one point from the beginning, then the flat Earth wouldn't have been a problem and the globe theory wouldn't have been considered. The story of Eratosthenes may be a lie, but whether it is a lie or not, the geometry of the globe does not change. Anyone with a knowledge of geometry would have no problem knowing the circumference of a globe or a circle. That story might have been created to make us think that the globe Earth theory has been calculated 2,000 years ago, therefore it is correct. But there are many reasons to doubt that experiment was real. By understanding this, we can know the aspects that must be studied and taken into account when creating an accurate model of the flat Earth, which better demonstrates reality and helps us understand the world as it is. Thanks to Nick for this collaboration, and by the way, I'm sorry for not posting any new content for the last 2 years. I have been going through a lot of issues, but I'm back now. So let's get down to business. Thanks for watching.